Welcome to my video tutorial on calculating pH from strong acid-base titrations. You'll have already carried out an acid-base titration, usually with hydrochloric acid and sodium hydroxide, using phenolphthalein as the indicator. The purpose of this so far has been to work out the concentration of the unknown acid or base when the concentration of one or the other is known. We can now use this analytical technique further and calculate pH. In this neutralisation reaction between sodium hydroxide and hydrochloric acid, you could add 0.1 molar hydrochloric acid from a burette to 25 centimetres cubed of sodium hydroxide that you'd have pipetted from a pipette of a concentration of 0.1 moles. Now the first thing you note here is that the base and the acid are both strong, and also the acid itself is monoprotic because it only has one hydrogen ion. Now you could use this data to find the pH of the solution in the flask at neutralisation, but you need to follow a few simple steps. Number 1, find the number of moles of each the hydrogen ion and the hydroxide ion by using the concentration times by volume. Don't forget volume has to be divided by 1000 to turn it into decimetres cubed. And also remember that for diprotic acid such as sulfuric acid, you'd have to multiply this by 2 because there are 2 hydrogen ions. Then you need to look at these two values and find out of the hydrogen ion and the hydroxide ion which is in excess, and then you calculate the number of moles of which one is in excess. Then you calculate the total volume of the solution and then convert that to decimetres cubed. Then you work out the concentration of the excess ions by dividing the excess moles by the volume. And finally calculate the pH. Now because we're dealing with strong acids and strong bases, if it's the acid that's in excess, then we can calculate pH easily from negative log to the base 10 of the hydrogen ion concentration. However, if the hydroxide ion is in excess, then we need to use Kw. So let's go back to that original neutralisation reaction, and let's just say that 23.50 centimetres cubed of the acid was titrated. So step 1, we need to calculate the number of moles of the hydrogen ion and the hydroxide ion. We do this by looking at the volume times by concentration. And don't forget to convert that volume by 1000. If you pop that into your calculator, it comes out as 2.35 times by 10 to the minus 3. Then for the hydroxide ion, this comes out as 2.50 times 10 to the minus 3. Now if you look at those two numbers, we have to identify which one's in excess. Well, the hydroxide ion is in excess, and we can calculate the number of moles of the hydroxide in excess, which comes out as 1.5 times 10 to the minus 4. Next we need to find the total volume, and you can see from the question that we've got 25 centimetres cubed of sodium hydroxide and 23.5 centimetres cubed of hydrochloric acid. So the total of that comes out as 48.5, and then obviously if we convert that to decimetres, it's 0.0485. Next we need to work out the concentration of the excess hydroxide ions, which is moles over volume, and if you pop that into your calculator, it comes out as 3.093 times 10 to the minus 3 moles per decimetre cubed. Our final step is now to calculate the pH, but we need to use Kw in this case because it's the hydroxide ions that are in excess. From our previous tutorials, we know that Kw has a value of 1 times 10 to the minus 14. We also know that Kw is equal to the concentration of the hydrogen ion multiplied by the concentration of the hydroxide ion, and rearranged, it will take this form. So if we pop the numbers in from previous, where we've got Kw over that concentration of the hydroxide ion, we'll find that this comes out as 3.233 times 10 to the minus 12. So now we've got the concentration of that hydrogen ion, we can now work out the pH, and remember that pH is equal to the negative log to the base 10 of the hydrogen ion concentration. So if we pop that into our calculators using the hydrogen ion concentration as 3.233 times 10 to the minus 12, that comes out as 11.49. And this is an expected value because the hydroxide ion was in excess, and this is obviously a value that you'd expect for a strong alkali. Sometimes the acid can be in excess. In this case, the calculation is a little easier. So let's take that other titration, but this time let's have 26.3 centimetres cubed of that 0.1 molar HCl being added to the flask. So following those steps, step number 1 is to calculate the number of moles of the hydrogen ion concentration originally, and not forgetting to convert that volume into decimetres cubed, and if you pop that into your calculators it comes out as 2.63 times 10 to the minus 3. Do the same for the hydroxide ion, and this time that comes out as 2.5 times 10 to the minus 3. So this time we can see that it's actually the hydrogen ion that's in excess. So we just need to work out how much exactly is in excess, and if we put that into our calculators it comes out as 1.3 times 10 to the minus 4. Step 3 is about calculating the total volume. So again in the question we can see what the volumes are, and then don't forget to convert that into decimetres to 0.0513. So our next step is to calculate the concentration of the hydrogen ion in excess. So that's number of moles over volume, and if you pop that into your calculator it comes out as 2.534 times 10 to the minus 3. Okay, so if we want to calculate pH this time, it's really straightforward because we've actually got the hydrogen ion in excess and it's a strong acid-base titration. So we can just use good old pH is equal to the negative log to the base 10 of that hydrogen ion concentration. And if we pop that into our calculators, we come out with a value of 2.60. And again, this would be expected because the acid is actually in excess and it's a strong acid-base calculation. And you can see that this is a much quicker way of calculating when the acid is in excess. To check your understanding, answer the following questions by calculating the pHs of these following mixtures. Make sure you do this before you watch my next tutorial. Thank you for watching. See you next time.